Since I saw Lightyear in theaters, I have wanted to have my own socks. After looking online at various features that various socks have, I have not been able to find one that has all the features I want, with the closest one I found being just a plain statue with only the cat in a box for $400 US, or the one that is capable of talking, which is a toy aimed at 8-year-olds. So because of this, I am planning to make my own. This will be a very long process as I have to figure out the entire path and build it from scratch, which will involve hardware, software, the frame, and making Sox Smart. Hardware is based around sensor choice and connection to the Raspberry Pi, along with purchasing and testing of all the components. Software is integrating all those sensors and outputs into Python inside the Raspberry Pi so that it can be functioning, and processing visually the images from the cameras that are going to be in Sox eyes. There is also going to be a need for servo control as Sox I want to have walk around. The frame itself will also take a very long time, as I will have to get a 3D printer, learn how to 3D model and then fine-tune said printer, and then iterate through various frame designs and wiring harnesses to make Sox functional and have all the wiring within a cat-sized object. I then want to make Sox Smart, which will include teaching the direction of up based off the gyroscope, along with walking and basic AI functionality, being able to say, "Hey Sox," and it being able to reply. Now this seems like a very linear path than the previous, but in reality it's going to be a chaotic path. It's going to be a lot of hopping back and forth between layers as stuff breaks and as better paths are found. But I'm hoping to keep it fairly linear so it's a good built up on a strong foundation of hardware. I'll be focusing on the hardware in the meantime, because without hardware there is nothing. And this brings me to the data path section of Sox. Data is the main thing that's going to be driving Sox. So everything is based off the Raspberry Pi that is going to be powering Sox. That Raspberry Pi will need to communicate with its battery, camera, and will have a tail data out via USB so it can be plugged into various devices, or have various devices plugged into it. The hat is a board that will sit on top of the Raspberry Pi, and it will be able to control the gyro, the servo controller, and the touch sensor, as I mentioned before. It will also have breakout wires to run up to the head of Sox, so that the microphone, laser, eye, and ear lights and speakers do not have to run all the way back to the Pi directly, making the wiring a bit neater and easier to get through the neck. Power is in a very similar way. There will be another USB supplying power into the battery to power up the Pi and the rest of the electronics as mentioned before. The hat will contain, as I said, the gyro, the servo, touch, along with the wires that break out to the head, which will include all the signals for the microphones, the eyes, the ears, and the laser. There will also need to be a special dedicated line for servo power, just due to the fact that servos take a lot more power and they run at 5 volts rather than all the logic that runs at 3.3 volts on the Raspberry Pi. The head contents will take all the wires from the hat that I mentioned go to the head, and then we'll have to be able to break out the individual wires to the sections that they are required in. So microphones, there'll be 2 sets of wires going out, 1 to each microphone to create stereo audio. There'll also be eye, ears, and lasers so that they can be controlled individually. There'll also be need for the speaker wire coming in from the audio jack on the Raspberry Pi, an amplifier circuit, and then the audio finally going out to the speaker. The past week's focus has been on the I2C, which is Inter-Integrated Circuit, which is a protocol that is used to communicate to many devices at once using only 2 wires, plus power and ground, which makes it a very, very simple structure to implement, yet is very robust and is quite well used. Inter-Integrated Circuit is usually used in PCB layouts, where it's used to talk between integrated circuits, which are known as chip, which makes it much more reliable than making my own system. Recently, I've got eyes to work. These are 2 cameras that are used in a stereo hat on the Raspberry Pi to take 2 images and mix them into one image with 2 sides on it. The left image is a little blurry because there's a fingerprint on the lens. I've been able to get the touch sensor to respond. Touching the pads in the sensor actually prints out the touch in real time. I've also been able to get the gyroscope operating on the I2C bus also, enabling acceleration and gyro. I've also been able to get the servo bus working, and I am looking forward to continuing this project. As I said, it's going to be a long one, and I am glad you are joining me on the journey. Thank you.